Experiment number 10 of Mechanics of Machines lab is about belt drives. The objective of experiment number 10 is to find the effort required to raise each load at given velocity ratio and to find the mechanical advantage at each load of belt drive. Belt drive. Belt drive is a mechanism in which power is transmitted by the movement of a continuous flexible belt. Belt is a loop of flexible material used to link two or more rotating shafts mechanically, most often parallel. Belts may be used as a source of motion to transmit power efficiently or to track relative movement. Types of belt drive. There are two types of belt drive, open belt drive and cross belt drive. In open belt drive, it is used to rotate the driven pulley in the same direction as driving pulley. As you can see in the figure, both driven pulley and driving pulley are rotating in counterclockwise direction. Cross belt drive. Cross belt drive is used to rotate driven pulley in opposite direction of driving pulley. As in the figure, you can see one pulley is rotating in counterclockwise direction and other one is in clockwise direction. Mechanical advantage. Mechanical advantage is a measure of the force amplification achieved by using a tool, mechanical device or machine system. The mechanical advantage of the belt drive is given by mechanical advantage equals to W over E, where W is equal to load applied and E is equal to effort required to raise that load. The belt drives are used to lift load, to transmit power and to apply force. Some applications of belt drives include floor mills, belt driving coolant pump, lubricant pump, AC, camshaft alternator, belt type continuous link bearing transmission, lathe machine and other machines, belt conveyors, transfer case in four-wheel drives. Apparatus description: 1. Beam, 2. Cone pulley, 3. Axle, 4. Belt, 5. Badge plate, 6. Logo badge, 7. Product label, 8. Name and number plate, 9. Cone pulley, 10. Axle, 11. Load hanger, 12. Load cord. Procedure: place a weight, say 5 Newton, on the right hand hanger. Find the load required to balance the system on left hand hanger. Repeat for a series of load at 5 Newton increment up to 15 Newton. Then plot the graph between load and effort. In table of observations, you will note free reading, load that you will apply on right hand hanger, effort that you will apply on left hand hanger, and the mechanical advantage that you will calculate using the formula load over effort. The graph between load and effort is a straight line graph, as there is direct relationship between load and effort.